Hello and good afternoon to everyone. So today is our second session on quadratic equation and complex number. Yesterday we did some questions on previous year questions of JEE Advanced, and today also we will be doing the same thing. Yesterday our major focus was quadratic. Today our major focus will be complex. So both the topics will be covered. Okay. So let us start our session. Okay. So here in the first question, it is saying to us that let alpha and beta be the roots of the equation px square plus qx plus r such that p is not equal to 0. If p, q, r are in AP and 1 by alpha plus 1 by beta is equals to 4, then the value of mod of alpha minus beta is how much? Okay. So from here, I can say that alpha plus beta upon alpha beta is equals to 4, right? So, first of all, if alpha beta are the roots of this equation, then alpha plus beta will be equals to minus q upon p, and alpha beta will be equals to r upon p, right? And one more relation that we know is that p, q, r are in AP. So, p, q, r are in AP. That means 2q is equals to p plus r. Or another thing that you can say is q minus p is equals to r minus q. Both the results point out to the same thing, that PQR are in AP. So this is alpha plus beta upon alpha beta value is 4. So alpha plus beta is minus q by p upon r by p is equals to 4. So pp gets cancelled. You get the relation minus q is equals to 4r, right? So from this, one more thing you can calculate. If minus q is 4r, then I'll substitute it here in this thing. So what I'll get here is 2 times of minus 4r equals to p plus r. So p will be minus 9r, right? So we got p as minus 9r, q as minus 4r. So PQR are in AP in this pattern. Now we have to find out mod of alpha minus beta. So to find out mod of alpha minus beta, we already know that mod of alpha minus beta can be written as under root of alpha minus beta whole square. And this under root of alpha minus beta whole square can be written as alpha plus beta whole square minus 4 alpha beta, right? So we already know the value of alpha plus beta is minus q upon p whole square minus alpha beta value is r upon p, right? From this relation. Okay. So this will turn out to be q square upon p square minus 4rp upon p square, right? So this will be equals to q square minus 4rp upon p square. Now we know that p in terms of r and q in terms of r, right? So I'll substitute these values in the given equation, like in the given root under root. So I'll get p q square. Q square is minus 4r, it will be 16r square minus 4r into 9 minus 9r. P value is minus 9r and upon p square. You will get p square as 81r square. So now this will come out to be 16r square plus 36r square upon 81r square. So r square will get cancelled. So it will come out to be 52 upon 81. So this will be 52. Root 81 will come out and it will become root 9. And 52 I can write as 4 into 13 upon 9. So this will become 2 root 13 upon 9. So the answer to our question is option B, 2 root 13 upon 9. I hope you guys understood the question. Let us, I hope you guys understood the question. Let us move ahead with another question. Now, here in this question, you can see that a square plus b square plus c square is given to us as 1, and we are supposed to find out the interval in which AB plus BC plus CA can lie. Okay. So first of all, to find this out, we all know that A plus B plus C whole square will always be greater than or equal to 0, right? If you square any term, it will always be greater than or equal to 0. So what is this value? A square plus B square plus C square plus 2AB plus 2BC plus 2CA is greater than or equal to 0. This value is given to us as 1. So can I write it as like this? 2 times of AB plus BC plus CA is greater than or equal to minus 1. And AB plus BC plus CA will be greater than or equal to minus half. Right? So from this you can know that the least value of AB plus BC plus CA will be equals to minus half. है ना? We all found out the least value of AB plus BC plus CA. Now to find out the greatest value of AB plus BC plus CA, we know that A minus B whole square plus B minus C whole square plus C minus A whole square. This will be also greater than or equal to 0. Now what I will do here is I'll expand each term. I'll get A square plus B square minus 2AB plus B square plus C square minus 2BC plus C square plus A square minus 2AC will be greater than or equal to 0. So here you can see guys that you are getting 2 times of A square plus B square plus C square minus AB minus BC minus CA as greater than or equal to 0. So we already know the value of this is 1. 2 can be taken out with this 0. So we are left with 1 minus AB plus BC plus CA is greater than or equal to 0. So from here you can conclude that AB plus BC plus CA will be less than or equal to 1. So from this thing we can understand that this this will be the maximum value of AB plus BC plus CA. So we found out the least value, we found out the maximum value. So AB plus BC plus CA, AB plus BC plus CA will always lie in the interval -1/2 to 1, right? So the answer to our question is -half to 1. So the answer is option C. So, so guys, in this question, you should remember that even if this question is not asked in the exam, the application of this method, the application of this method can surely be asked because most of the students would not be able to recognize how, why and when to use this equation. Okay. So generally this equation is used with half over here, but since the right side was 0, I neglected that half and continued with the equation itself. So please make sure you remember that this particular thing will be useful to you guys. Okay, let us move on to the another question. Now, in this question, you guys can see that we have been told x square plus px plus q equals to 0 has roots as tan 30 and tan 15 degree respectively. Then the value is 2 plus q minus p. Okay. So here tan 30, let tan 30 be alpha and tan 15 degree be beta. So here you can see that alpha plus beta is equals to minus p and alpha beta is equals to q. We are getting this result from the quadratic equation. We are getting this result from the quadratic equation. Now I know that tan 45 degree can be written as tan 30 plus tan 15. Tan of 45, I am splitting this 45 in two angles, that is 30 degree and 15 degree. So tan of A plus B is tan A plus tan B upon 1 minus tan A tan B. Now we all know the value of tan 45. Tan 45 is 1 and tan 30 is our alpha, tan 15 is our beta upon 1 minus alpha beta, right? So I will substitute the values as it is given to us. So after substituting the value of alpha plus beta as minus p, I will be left with 1 minus p upon 1 minus 1 equals to minus p upon 1 minus q. From here I will multiply 1 minus q and this will become 1 minus q equals to minus p. I will take the q on that other side. It will become 1 equals to q minus p. Now we have found the value of q minus p. Q minus p is equals to 1. So therefore 2 plus q minus p will be equals to 3. Right? So this was a very easy question. And please remember that this trick can be used somewhere else also in our subject. So tan 45, since the value of tan 45 is 1, most of the times they give us some other angles and we have to split it into such a way that the sum will be 45 and we have to apply the formula of tan. Okay, so this is the trick here. If you knew this, this would have been easier. Let us move on to another question. Now, here in this question, this is a question of complex number as you guys can see. So now we are slowly and steadily, we have advanced to the topic of complex numbers. Here in this question, if z is equals to x plus iy is a complex number where x and y are integers, then the area of the rectangle whose vertices are the roots of the equation. So if z is x plus iy, then z conjugate will be equal to x minus iy, and mod of z will be equals to under root of x square plus y square, and mod of z square will be equals to x square plus y square. So these are the results that we will be using in for solving the question. And one more result, that z conjugate is equals to mod z square. So this is a very important result. Many questions have been asked based on this result previously in IIT JEE mains as well as advanced. So what I'll do here is, in the given equation, z conjugate cube plus z conjugate z cube is equals to 350. In this equation, can I write it as, first of all, I'll write this as z conjugate into z conjugate square plus z conjugate z into z square equals to 350, right? So we all know that z conjugate is what? Z conjugate is equals to mod of z square. I'll be directly applying that here. I'll be writing mod of z conjugate is equals to z square into z conjugate square. Now z conjugate square will be x minus iy whole square plus, here as well I will write mod of z square into z square x plus iy whole square equals to 350. So now guys, can I take mod of z square common, and in the inside we will be left with x minus iy whole square plus x plus iy whole square is equals to 350, right? So I will be solving this in the next slide further. So that will become, I'm writing it again, x plus iy whole square plus x minus iy whole square is equals to 350. Now mod of z square we already know it is equals to x square plus y square. And here inside it will become x square plus 2 ixy plus iy square, which is minus y square, plus x square minus 2ixy minus y square equals to 350. So this 2ixy's will get cancelled and inside there will be 2 times of, here it will become x square plus y square into 2 times of x square minus y square is equals to 350. Now if you multiply this, I'll cut the two I'll take the 2 on the right side and this will leave us with 175. So we will get x square plus y square into x square minus y square equals to 175. Now this is in the form of a square plus b into a minus b, which is equals to a square minus b square 175. This will become x power 4 minus y power 4 equals to 175. So here can I write 175 as 25 into 7, right? If I write x square plus y square into x square minus y square as 25 into 7, then can I say that x square plus y square will be equals to 25 and x square minus y square will be equals to 7. Since x square plus y square will obviously be greater than x square minus y square. And one more thing, we have done this because x and y are supposed to be, x and y are integers, right? So there was another possibility to write this 175. It was 37 into 5 as well. You could have 35 into 5 as well. So when you choose 35 into 5, then you won't get x and y won't come out to be integers. So that is why 25 and 7 is chosen here. So after I add these two, I will get 2x square equals to 32. So x square will be equals to 16, x will be plus minus 4. And similarly, if x is plus minus 4, then y square will be 16 minus 7, which will be 9. So y value will be plus minus 3. Now you got x equals to plus minus 4 and y equals to plus minus 3. So from this the vertices that can be put together is 4 comma 3, 4 comma minus 3, minus 4 comma 3 and minus 4 comma minus 3. So the area of this 4 comma 3 will be somewhere here, 4 comma minus 3 will be here, minus 4 comma 3 will be here, minus 4 comma minus 3 will be here. So this is minus 4 comma 3, minus 4 comma minus 3, this is 4 comma 3, this is 4 comma minus 3. So as you can see, this forms a rectangle. So the area enclosed by the rectangle will be the product of length into breadth. So this length is coming out to be 8 and this breadth is coming out to be 6. So the area is 8 into 6, 48 square units. Therefore, the answer to our question is 48 square units. So as you can see, answer will be Option A, which is 48 square units. I hope this question was understood, guys. Now, in this question, you must remember that these properties were used. Okay, and this is the most important one which helped us get to the answer. Z conjugate is equals to mod Z square. So this property might help you in a lot many ways in questions of complex number. Moving ahead with another question. Moving ahead with another question. Here, this question, in this question is pretty interesting. Why? Because here you have been given as, so you must have studied the nth root of unity topic, right? Nth roots of unity, right? So in this question, you need not require to find like what the roots will be in terms of cos plus I sine. And you don't need to find this thing, but the important thing that important property that will be used here is to find all these values. There we had written, let's say that x power n is equals to 1, right? Now x power n minus 1 is equals to 0. So if x power n minus 1 is equals to 0 and we know the roots of the equations 1, a1, a2, a3, up to an minus 1. So can we write this in terms of the factors x minus 1 into x minus a1 into x minus a2 into x minus a3 and so on up to x minus a n minus 1, since there are n roots, right? So what I'll do here now is I will, since in the question you can see that only a1 part, a2 part and up to an minus 1 part is there. So we have to keep this, we have to keep this part, this part till the end part in our equation, and that is why I will be taking this x minus 1 below. So this will become x power n minus 1 upon x minus 1 is equals to x minus a1, x minus a2, x minus a3 up to x minus a n minus 1. Right, guys? Now I'll be solving this another part in the next slide. So let me write it down again. This came out to be x minus a1 into x minus a2 into x minus a3 up to x minus a n minus 1, right? So here the beauty of this part is that, do you remember where have you seen, where have you seen such terms previously? Do you remember that this is something that we have seen somewhere but you are not able to remember it properly? Yeah? Does it look something familiar to you? Yes, it actually is familiar to us. Where, do you know, can you tell me the sum of the GP x power n plus x power n minus 1 plus x power n minus 2 up to x square up to 1. So what is this? This is a GP. In this GP, the first term is x power n, and what is the sum of GP formula? First of all, tell me that. The sum of, what is the formula of sum of GP? Sum of GP is equals to a into 1 minus r power n. So I am saying the first term is 1. I am taking considering this GP to be reversed. So this will be 1a into 1 minus r power n upon 1 minus r. So here since the number of terms were n plus 1, the power came out to be n plus 1. So for the power to be n, what should be there? The number of terms should be n, right? So the GP will be x power n minus 1 plus x power n minus 2 plus x power n minus 3 so on up to 1, right? So this will be equals to 1 minus x power n upon 1 minus x, which is also equals to x power, which is also equals to x power n minus 1 upon x minus 1, right? So that is why we conclude that this thing is equivalent to this thing, right? X power n minus 1 upon x minus 1 is equals to the sum of this GP. Okay, so this was the important part and trick involved here. Now, in the next slide, let's see. So can I write this x power n minus 1 upon x minus 1 equals to whatever it was, x minus a1 into x minus a2 into x minus a3 dot 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 up to x minus a n minus 1, right? So now this we already know. I am substituting that sum of GP in this here. This will become x power n minus 1 plus x power n minus 2 plus x power n minus 3 so on up to 1 equals to x minus a1 into x minus a2 into x minus a3 dot 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 up to x minus a n minus 1, right? So now in if I substitute, now see the question. The question is asking there is 1 everywhere, there is 1 in place of x, right? So here they want 1, here they want 1, here they want 1, and here they want 1. So what can we do is if we substitute x equals to 1 on both the sides of the equation and both sides of equation, then what we will get is we'll get 1 plus 1 dot 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 plus 1. This will be n times since there are n terms there, and this will become 1 minus a1 into 1 minus a2 into 1 minus a3 up to 1 minus a n minus 1, right? So the value of this thing, the question which has been asked to us is 1 minus a1 into 1 minus a2 into 1 minus a3 1 minus a n minus 1. This will become n, right? Since here there are n terms and the sum of 1 up till n times is n. Okay guys, I this question was a nice question and tricky also. So you should remember the trick. You should know what x power n minus 1 upon x minus 1 can be written. So this is the trick involved here. I hope you guys, if this type of question comes in exam, you guys will be able to tackle it. So moving on to the next question. Now, in this question, you guys can see, that it has been given to us that mod of z plus I mod of z plus I upon z minus I is equals to root 3. Then the radius of the circle. Then the radius, we have to find the radius of the circle. So this equation is the equation of a circle. Okay. So what we will do here is I'll say let z be equals to x plus iy. So now this will become is mod of z plus I, which is x plus iy plus I upon x plus iy minus I is equals to root 3, right? So here this can be written as x plus I times y plus 1 upon x plus I times y minus 1. The modulus is root 3. Now we know the modulus of we know that the modulus of a complex number, modulus of any complex number z is written as x square plus y square. So the modulus of x plus I times y plus 1, x plus I times y plus 1 will be equals to under root of x square plus y plus 1 whole square, and modulus of x plus I times y minus 1 will be equals to under root of x square plus y minus 1 whole square. So we have to divide these two things, and the division, like the root of x square plus y plus 1 whole square upon x square plus y minus 1 whole square is given to us as root 3. So therefore, squaring both sides, you get to know that x square plus y plus 1 whole square will be equals to 3 times x square plus y minus 1 whole square. Now simplifying this, you will get x square plus y square plus 2y plus 1 is equals to 3x square plus 3y square minus 6y plus 3, right? So I'll take all these terms on the right hand side. I will get 2x square plus 2y square minus 8y plus 2 equals to 0. So now I found out the equation of the circle. If you take 2 common, the equation of the circle will become x square plus y square minus 4y plus 1 equals to 0. So if you remember the topic circles, in the circle the equation, after we found out the equation, the radius used to be under root of g square plus f square minus c. Now here g value is 0, f value is 2 minus 2, and c value is 1. So g square plus f square minus c radius will be equals to under root 0 plus 4 minus 1 equals to root. So the radius of the circle, this circle is equal to root 3, guys. So I hope this question was understood by each and everyone. This question was pretty easy. You just had to assume a complex number and arrive at the equation of the circle. Arrive at the equation of circle, and you must have been able to get to the answer. Okay. Let us move ahead and try to solve another question. Now, guys, here alpha and beta are the distinct roots of this equation. X square minus x plus 1 equals to 0. So alpha beta are the distinct roots of this equation. which means what? Do you know that this equation has complex roots since since discriminant is less than 0? Okay. So what are those roots? X equals to minus b plus minus under root b square minus 4ac will be minus 3 upon 2, right? So this will be 1 plus minus root 3 I by 2. So you got the value of x. So this you we all know that minus 1 minus 1 plus minus root 3 I by 2 used to be what? Omega and omega square. So in this question, x will be equals to minus omega and minus omega square, right? So let alpha be equals to minus omega square and beta be equals to minus omega. So from this thing, alpha power 101 plus beta power 107. We have to find out this value. So alpha power 101 will be minus omega square power 101 plus minus omega power 107. So this will become minus omega power 202 minus omega power 107. I will take common. This will become omega power 202 plus omega power 107. So now we have to find out the value of this thing. So we already know, we know what? We know that omega cube is supposed to be 1 because it is also a cube root of unity. Omega cube is supposed to be 1 because it is a cube root of unity. Now alpha power 101 plus beta power 107 was minus omega power 202 plus omega power 107. Can I write this as minus omega power 201 into omega plus 107 is 8. So omega power 105 into omega square, right? So what this will become? Minus omega power 201 can be written as omega cube power 67 into omega plus omega cube power 35 into omega square. So this will become minus. We already know that omega cube is 1. So this will be 1 into omega plus 1 into omega square. We got minus times omega plus omega square, right? So this is minus omega square. So the quadratic equation which was given to us was x square minus x plus 1 equals to 0. And the roots were minus omega square. So the sum of the roots will be equals to 1, right? In the quadratic. So this is alpha plus beta, right? So this is alpha plus beta, which is equals to 1 in the given quadratic equation. So that is why the value of the value of the question alpha power 101 plus beta power 107 will come out to be 1. So here in this question, the important part to remember was, first of all, you should remember that x cube minus 1 can be written as x minus 1 into x square plus x plus 1. So the roots are cube root of unity is 1 omega and omega square. So since these are cube roots of unity, omega cube is also equals to 1, right? So we have used this property as well as the property that the roots of x square minus x plus 1 roots will be minus omega and minus omega square. So these are two things we must remember while solving cube roots of unity question. Let us move on to another question. In this question, the question is asking us the region represented by z equals to x plus iy is element of complex number such that z minus real part of z is less than equals to 1. Can also be written by the inequality. So out of the four options, which inequality will also represent this, that z minus real part of z is less than equal to 1, right? So first of all, we know that mod of z is under root x square plus y square and real part of z is equals to x. Now z minus real part of z less than equals to 1. So here I guess the question should be mod of z, guys. Mod of z minus real part of z. So this will become under root of x square plus y square minus x is less than equals to 1. You will take this x to that side. This will become less than equals to 1 plus x. Now x square plus y square will be less than equals to x square plus 1 plus 2x. X square will get cancelled. What we can, like, what did we get here is y square is less than equal to 2x plus 1. So y square is less than equals to 2 times x plus half. So this was a very easy question, guys. The answer is option A. Y square is less than equals to 2 times of x plus half. Okay, guys. Okay. So in the next class, we will solve questions on vectors and 3D, which is also one of the most important topic for JEE Advanced due to its weightage. So whoever is watching, please come and watch the class on Monday. Thank you so much, guys.